Hey guys, we're going to keep lesson 11 here in module 4 pretty short. You'll see why in a minute, but it's important work and it's stuff that you'll do, later in your math career as well. Sort of finding all the pairs of numbers that multiply together to create the same product. And we can do that using area, but it's not necessarily a lesson that we need to spend a ton of time on. I'll show you how it's done, and then once you understand how to do it, I'm going to send you off on your own to actually do it. Here we go. As has been the case in this module, because there's so much drawing and you know what a terrible artist Mr. Burnell is, I just brought the problems at home to work on because it will save you the trouble of having to watch me draw stuff probably inaccurately. So the rectangles below all have the same area. So I'll scan down and show you all of those have the same area. They probably don't look like it to you at first, but they do. Move the parentheses to find the unknown side lengths, then solve. So 8 times 6 is 48. So the area is 48 square centimeters. So the area of all of these is going to be 48. And again, the purpose of this lesson is to show you that multiple combinations of numbers can multiply to the same thing. Basic example of that, 50 is made up of 5 times 10, but it also can be made up of 2 times 25 or 1 times 50. So there are multiple ways to get to the same product. So if I have 1, this must be 48. 1 times 48 is 48. 48 square centimeters. Now becomes the process of moving parentheses around like mentioned at the beginning there. So 8 times 6, that original one that I had up here on the left, I can turn that 8 into a 2 times 4, right? And now I can put my parentheses around the 4 and the 6. So I have 2 times 24. 2 times 24, or 24 plus 24, is also 48. Okay. Again, I can take my 8 and I can turn it into a 4 times 2 again. And I can do, let's see, 4 times 2, 2 times 6 there. Right? This time I just flipped the, I did 4 times 2 on both of them. I just changed which one I was going to combine with the 6 this time. So I end up with 4 times 12. 4 times 12 is, you guessed it, 48 square centimeters. And lastly, I'm going to leave the 8 alone, and I'm going to take the 6 and turn it into a 2 times 3, and then combine my 2 together to get a 16 times 3. And since we already know that the areas all work out the same, 16 times 3 is 48 square centimeters. Let's see. Does problem 1 show all the possible whole number side lengths for the rectangle with an area of 48 square centimeters? How do you know? I'm going to say no, it doesn't, because here we broke up the 8, broke apart the 8 and used it by 4 times 2 in one case and 2 times 4 in the other. But with the 6, we only did that once. So I think we should try it the other way. So 8 times 6 equals 8 times. Last time we did 2 times 3, so let's do 3 times 2 here. Oh, I might be wrong. Whoops. That's not the first time that's happened. Let's see. We can put 8 times 3 in parentheses times 2. We get 24 times 2. Yeah, we already did that one. So I showed some work. I tried something, and turns out we have exhausted all of our options. So you would be able to say this, we have covered all the possible options other than, rotating or turning our rectangles on their sides. All right. So again, doing this, like taking the 8 and breaking it apart into a 2 and 4, or 4 and a 2, or taking a 6 and turning it into a 2 and a 3, or 3 and a 2, that's not new. That's something we've done before. This time we're just being more exhaustive in that we are covering all of our options. We're sort of seeing all of the ways to make 48 with multiplying whole numbers together. Let's see. it says in problem 1, this is just like an observation sort of question. So I'll flip back to the other side in a minute. What happens when to the shape of the rectangle as the difference between the side lengths gets smaller? So like 1 times 48 or 2 times 24, the difference between the side lengths, the 1 and the 48 or the 2 and the 24, that's really large, right? There's 47 difference between one of them and a 21 and the other. So that's huge. But, right, when you have 6 and 8, those are only different by 2. And when you have even, 12 and 4, that's only off by 8. 3 and 16 is off by 13, but even that's, that's sort of somewhere in the middle. So what do you notice there? Well, I notice that when the difference is big, they are like long, skinny rectangles. And when the difference is smaller, they turn more into, for lack of a better word, like shorter, fatter rectangles, right? And so that is what problem 3 is getting at. Like big difference. You should write this in a sentence. I'm not going to because, for time's sake, but big difference equals long, skinny rectangles. Small difference equals shorter and wider. We use wider. No. Yeah, I guess we wider rectangles. Okay. All right. This one says find the area of the rectangle below. Well, 8 times 9 equals 72. We went over for a week different ways you can solve 9's facts. So 72 square centimeters. You could use any number of tricks or strategies rather to figure that out. Julia says that 4 times 8 centimeter rectangle has the same area as the rectangle in part A. Place parentheses in the equation to find out the related facts and solve. Is he correct or why or why not? Well, so we took 4 times 18. We took the 18 and we turned it into we broke it apart and we showed that it could be 2 times 9. So I'm then going to combine I'm then going to combine 2 and the 4 to get 8 times 9 is 72. So we did it. We took that and we turned it into that, which is what we first started with. So he is correct, right? We were able to move the parentheses around and show that 4 times 18 is the same as 8 times 9. Again, not new work. We had a whole unit on doing this sort of thing, manipulating the 2 factors to get the same product. It says on the last part, here, I'll come down here so you can see better. Use the expression 8 times 9 to find the different side lengths a rectangle has for a rectangle that has the same area as the rectangle part A. Show your equations using parentheses, then estimate and draw a rectangle and label the side lengths. I'm going to do one for you. I'm not going to do them all, but I'll show you the process one more time. So 8 times 9 equals, I'm going to take the 9 and break it into a 3 times 3. So 8 times 3 times 3, right? So we could turn that into 8 times 3 in parentheses times 3. 8 times 3 is 24 times 3. So that equals 72 square units. And that is my rectangle. Oops, I drew off my page there. 324. And that's one that you could do. You also could have broken apart the 8 and done it that way. All right, so take the 8 and turn it into a 4 times 2 and combine those with a 9. Right, we already know that one of those turns into 4 times 18, and then we could find the other one if we did it and multiplied the 4 and the 9 together first. 36 times 2. That would be the other rectangle we could make. And that is the end of this lesson. So again, we're drawing back to some strategies or going back to some strategies that we've used in modules 1 and 3, and we're just applying them to problems involving area at this point. All right, guys, we are on a roll. You guys are doing an awesome job. Keep it up. Keep working hard.